Alright, let's do this question. Chris got X marks, Donna got Y marks, Bob got an integer number of marks between X and Y. How many possibilities are there for the marks that Bob got? Statement 1 says Donna got 10 marks more than Y or Chris. Alright. Statement 2 says the marks got by Donna and Chris are integers. Alright. Pause the video, give it a try, and then let's do it together. Alright. I hope you have given it a try. Let's do it together. Now, Chris got X marks and Donna got Y marks. Let's say that Bob got B marks. Now, statement 1 says that Donna got 10 marks more than Chris. Alright. So, if Chris got X marks, Bob got somewhere between X and X plus 10 because Donna got X plus 10. Alright. Now, is this sufficient to find out all the possibilities for the marks obtained by Bob? That's what we need to find out, right? How many possibilities are there for the marks that Bob got? And remember, Bob got an integer number of marks. Alright, now if X is equal to 2, that is if Chris got 2 marks, then Bob got somewhere between 2 and 12, right? Donna would have got 2 plus 10, which is 12 marks. So there are 9 possibilities, right? Because that's 3, you have 4, 5, 6, 7, 8, 9, 10 and 11. So that's 3, 4, 5, 6, 7, 8, 9. So you have 9 possibilities. Is that the only case? If Chris got 2.1 marks, then Donna would have got 12.1 marks, right? Now in this case, you can see there are 10 possibilities. There are all these 9 possibilities, and in addition to that, you have 12 also. So there are 10 possibilities. Therefore, you can see that using statement 1 alone, you cannot find the answer. Statement 1 alone is not sufficient. So this is a trap. If you did not see this part, then you would have marked that this question can be solved with statement 1 alone. Alright, now what about statement 2 alone? The marks got by Donna and Chris are integers. If we use this statement alone, there's nothing that helps us, right? It could be anywhere, anything. It could be 1 and 100, or it can be 1 and 10, or anything. So statement 2 alone is clearly not sufficient. But if you combine statement 1 and 2, then this is ruled out, right? These two have to be integers. Therefore, we are only left with one possibility. That is, there are 9 possible marks that Bob could have got. Therefore, the correct answer to this question is option C. Let's do this question. Bob went to the market and bought oranges. How many did he buy? Alright. Statement 1 says if he gives 5 to Manu, he has fewer than 22 oranges. Statement 2 says if he buys 5 more, he will have at least 30 oranges. Pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Let's do it together. Now, statement 1 says if he gives 5 to Manu, he has fewer than 22 oranges. Let's say that he bought X oranges. So if he is giving 5 away, he'll have X minus 5, and that will be less than 22. Right? That's what statement 1 says. So this means that X is less than 27. This alone is not sufficient, right? You can have 26 or 25 or 10. You can have multiple answers. So you don't get a unique numerical value. So this statement alone is not sufficient. What about statement 2 alone? If he buys 5 more, he will have at least 30 oranges. So if he buys 5 more, he will have X plus 5 oranges. And that is at least 30 oranges. So that means X plus 5 is greater than or equal to 30, right? Now this is greater than or equal to. That means X plus 5 can be 30 or 31 or 32 or 100. Alright, so therefore X is greater than or equal to 25. Again, it's not sufficient, right? You can have the value of X as 25 or 26 or 27 or anything greater than 25 or 25 itself, right? So statement 2 alone also is not sufficient. Now let's combine these two statements. Now X is less than 27. So the values that X can take is 1 up to 26, right? Now over here, X is greater than or equal to 25. So the values that X can take is 25, 26, etc. Now, what's the intersection between these two? You can see that you have 25 and 26 in both. So again, even if you use both the statements, two possibilities are there. Therefore, we are not getting a unique numerical answer even when both the statements are used, and hence the correct answer to this question is option E. Let's do this question. xy is greater than 0. Is x minus 1 into y plus 3 equal to minus 3? So this is a yes or no question, right? Now statement 1 says y minus 3x is equal to xy, and statement 2 says x is equal to y. Now pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Let's do it together. Now this is what we need to verify, right? Now first let us simplify. Alright, now x minus 1 into y plus 3 is equal to minus 3, right? So I open the brackets, I get xy plus 3x minus y minus 3 is equal to minus 3. Alright, so these two cancel out, right? So I have xy plus 3x minus y is equal to 0, or I can say that y minus 3x is equal to xy. Alright, so this is just on simplifying the question stem, right? I've not used any of the given statements yet. Now let's check statement 1. It says that y minus 3x is equal to xy. That is exactly what we got over here. Therefore, statement 1 is sufficient. If this is true, then this is true and I have a definite yes, right? So statement 1 alone is sufficient. What about statement 2 alone? Statement 2 alone can give you a yes or a no. So it's not sufficient, right? So when is it a yes and a no? Let's check that. Now, if you use the value of x and y as minus 2 and minus 2, that is, if you substitute x is equal to y into this equation over here, you will get x minus 3x is equal to x square. So you get minus 2x is equal to x square. So let's take this to the right hand side. So you get x square plus 2x is equal to 0, or x into x plus 2 is equal to 0. Now this will be true when x is equal to 0 or x is equal to minus 2. Now remember, in the question it is given that x into y is greater than 0. So x is equal to 0 is not possible. So therefore this equation over here will be true only when x is equal to minus 2 and y is equal to minus 2, right? Because that's what we started with, x is equal to y, right? Now therefore x is equal to y will give you a yes when you take the values of x and y as minus 2 and minus 2. Now if you take the values of x and y as something else, like for example 1 and 1, then you will get a no, right? If you substitute 1 and 1 over here, 1 minus 1, that's 0. So the left hand side is 0 and 0 is equal to minus 3, that's a no. So you're getting a no over here, and in this case you're getting a yes. So there is no definite yes or no. Therefore statement 2 alone is not sufficient, and as statement 1 alone is sufficient, the correct answer to this question is option A. Let's do this question. What is the value of x square minus y square? Alright, so that's what we need to find out. Statement 1 says x plus y the whole square is equal to 25, and statement 2 says x minus y is equal to 3. Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. Let's do it together. Now we know that x square minus y square is equal to x minus y into x plus y. So we have covered this in the algebraic identities that we discussed in the algebra basics section, right? Alright, now statement 1 says that x plus y the whole square is equal to 25. Now remember, when you have a square over here, x plus y can be plus 5 or minus 5, right? Because plus 5 the whole square is also 25, and minus 5 the whole square is also 25. So over here you don't get a definite answer plus for x plus y, right? And at the same time you cannot find out x square minus y square also. So statement 1 alone is not sufficient. Alright, what about statement 2? Statement 2 gives you x minus y is equal to 3. So that also is not enough to find x square minus y square, right? You need x minus y and x plus y. So statement 2 alone is also not sufficient. What about statement 1 and 2 together? Statement 1 and 2 together also will not be sufficient. Can you tell me why? It's because over here you can see that x plus y can be plus 5 or minus 5, right? And x minus y is given as 3. So x square minus y square is x minus y into x plus y. So it can have two values, right? It can have the value as 5 into 3, which is 15, or minus 5 into 3, which is minus 15. So we are not getting one unique numerical value, and hence the correct answer to this question is option E. That is, this question cannot be solved even using both the pieces of information given in statement 1 and statement 2. Let's do this question. A tour guide charges $X for the first 3 days and then $0.5x for every subsequent day or fraction of a day. Did John hire the tour guide for more than 10 days? Statement 1 says John had to pay him $200, and statement 2 says John had to pay him $5x. Pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Let's do it together. Now, statement 1 says John had to pay him $200. Now, let's write an equation. For the first 3 days, he's paying him X dollars, right? Now, let's say that he hired him for a total of D days. Alright, so I can say that X plus D minus 3 into 0.5x is equal to 200, right? For the first 3 days, he's paying him X dollars, and for the remaining D minus 3 days, for each day, he has to pay him 0.5x dollars, and the total is 200. Alright, let's try to simplify this. Now, this is 1 by 2x, right? So let me multiply the equation throughout with 2. So I get 2x plus x into D minus 3 is equal to 400. Alright, now I have x over here and x over here. So let me take that out. So I get x into 2 plus D minus 3 is equal to 400, or x into D minus 1 is equal to 400. Alright, now this is not sufficient to find out whether D is greater than 10, right? I could take D as 11, and in that case I have 40 into 11 minus 1, which is 400, or I can take D as 5, and then 100 into 5 minus 1 also gives me 400. So in this case, D is more than 10, so I have a yes over here, and in this case D is not more than 10, so I have a no over here. So I'm not getting a definite yes or no. Therefore, statement 1 alone is not sufficient. Alright, what about statement 2 alone? It says that he had to pay him $5x. So let's write the equation. X plus D minus 3 into 0.5x is equal to 5x. Now you can see that this statement is sufficient, right? You have x throughout, right? And x is a positive number, so you can cancel it and you have an equality over here. We'll see more of that in sessions where we discuss inequalities. But over here you have x, and x is not 0. So if you have a positive non-zero value, then you can cancel it, right? Even if it's negative and you have an equality, there's no issue. And again, as I repeat, we'll discuss more of inequalities in a separate section. Over here you have x, x and x is not 0, so you can cancel it out, right? Now therefore, you don't need to find D actually. You just need to know that you can find D. You have one equation over here. After x is gone, there will be just one variable, which is D, right? So you can find D, and that is enough to identify that statement 2 alone is sufficient. And therefore, the correct answer to this question is option B. Now, because I hinted on the part where x is not 0 for cancelling, let me quickly explain that over here. Now, say I have an equation AB is equal to AC. Now, can I say that B is equal to C by cancelling out A from both sides? I can't do that unless I know that A is not equal to 0. If A is not equal to 0, then yes, I can do it, right? But if A is equal to 0, then I can't do this, right? So 0 into 1000 is equal to 0 into 10. So I can't cancel the zeros and say 1000 is equal to 10. So you can do this only when you know that A is not equal to 0. In this case, it's definitely not 0, right? Because he has to pay him some amount. So that's why we can cancel it out on both the sides and we can find the value of D. Alright. So statement 2 alone is sufficient, and the correct answer is option B. Let's do this question. X is the greatest among 3 different integers greater than 1. What is the value of X? Statement 1 says the product of the 3 integers is 525, and statement 2 says one of the integers is 3 times one of the other two integers. Pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Let's do it together. Statement 1 says the product of the three integers is 525. Let's factorize 525. Alright, so I can see that 525 can be written as 5 into 5 into 3 into 7. Alright, so I can express these as 3 into 7 into 25. The three numbers could be taken as 3, 7 and 25, or I can take it as 3, 5 and 35, etc. Right? So clearly this statement alone is not sufficient, right? I need to find the greatest. In this case, the greatest is 25, and in this case, the greatest number is 35. So it's not sufficient. I'm not getting a unique numerical value. Alright, what about statement 2 alone? Statement 2 alone says one of the three integers is 3 times one of the other two integers. So that also does not give me any idea about the value of the integers, right? Therefore, statement 2 alone also is not sufficient. What about statement 1 and 2 together? So I know that the product of the integers is 525. So that's 5 into 5 into 3 into 7. And statement 2 says one of the integers is 3 times one of the other two integers. So you can see that there is only one possibility of combining these two pieces of information together. The numbers have to be 5, 5 into 3 and 7. So over here you can see that 15 is 3 times 5. Now in this case you can find the value of x, and therefore the correct answer to this question is option C. That is, you can solve it only by using both the given pieces of information. Let's do this question. A square plus b square is equal to 25. What is the value of a plus b the whole square plus 4ab? Now statement 1 says ab is equal to 12 and statement 2 says b is equal to 4. Pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Now this is a classic D trap. Alright, now the options are A, B, C, D and E. So in a lighter manner, we could classify the traps as A trap, B trap, C trap, D trap and E trap. Right, now we have already seen previously questions where the trap was C, which we call as C trap questions. Now this is a typical D trap question. Let's see why. Now over here, statement 1 says that AB is equal to 12 and it's given that a square plus b square is equal to 25. So definitely statement 1 alone is sufficient, right? Why is that so? A plus b the whole square plus 4ab is nothing but a square plus b square plus 6ab, right? And a square plus b square is given in the question, that's 25, and ab is given in this statement. So definitely statement 1 alone is sufficient. Alright, what about statement 2? It says that b is equal to 4. We know that a square plus b square is equal to 25. Now, if b is equal to 4, then a can be plus or minus 3, right? This is the trap. If you assume that a is definitely 3, then you have fallen into the trap and you will mark the answer as option D. But that's not true, right? A is plus or minus 3. And therefore, statement 2 alone is not sufficient to solve this question, because if you put a as 3 or a as minus 3, you'll get different answers for this one, right? Okay, so statement 2 alone is not sufficient, and therefore the correct answer to this question is option A. Let's do this question. J is a set of 10 numbers A1, A2, A3, etc. up to A10. Alright, is the range of the numbers in J greater than 4? Now statement 1 says A1 and A2 are two different multiples of 4, and statement 2 says A1 minus A4 is greater than 4. Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Let's do it together. Now statement 1 says A1 and A2 are two different multiples of 4. Alright, so let's plug in some numbers. I could take A1 and A2 as 4 and 8. Right, in this case, assuming that 4 is the least number, again it's an assumption, but even if I assume that, if I assume 4 is the least number and 8 is the greatest number, alright, so in this case I get the range as 8 minus 4, which is equal to 4. So I'm getting a no over here. Now if I take A1 as 4 and A2 as 12, then the range is 12 minus 4, which is equal to 8, and I'm getting an yes. So I get sometimes no and sometimes yes. So clearly statement 1 alone is not sufficient. Alright, now what about statement 2? Statement 2 says that A1 minus A4 is greater than 4. And the question is the range greater than 4? So definitely statement 2 alone is sufficient, right? Because the difference between two numbers is greater than 4. So the range of the given numbers, which is the difference between the greatest and the smallest number, is definitely greater than 4. Therefore, statement 2 alone is sufficient, and hence the correct answer to this question is option B. Let's do this question. At a certain fruit stall, each orange costs X dollars and each apple costs Y dollars. If $20 is enough to buy 6 oranges and 4 apples, is $20 enough to buy 5 oranges and 5 apples? Alright, statement 1 says the price of each orange is less than $2, and statement 2 says $20 is enough to buy 12 oranges. Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Let's do it together. Now over here I can say that 6x plus 4y is less than or equal to 20, right? 6x is the amount of money required to buy 6 oranges, and 4y is the amount of money required to buy 4 apples. And that has to be less than or equal to 20, so that $20 is sufficient. Alright, now the question says 5x plus 5y, is that less than or equal to 20? That's the question, right? Now, this question actually is a sitter. It gives us very little information. Let's try to analyze it. Now, 6x plus 4y is less than equal to 20. In this case, I could take 6x plus 4y as 1, alright, or 6x plus 4y could be equal to 20 as well. Alright, now statement 1 says the price of each orange is less than 2. Now this is clearly not sufficient. Let's try to understand it. Let's say that we take 6x is equal to 0.6 and 4y is equal to 0.4. So 0.6 plus 0.4 is equal to 1. Alright. Now in this case, I'm taking x as 0.1, right? And y as 0.1. Alright. Now if this is the case, then you can see that if I take 5x and 5y, I have 0.5 and 0.5, and that is equal to 1. So I am having a yes over here, right? We took 1 over here. So 0.5 plus 0.5 also is equal to 1. So I'm getting a yes over here. Now, if I take 6x as 6 and 4y as 14. So 6 plus 14 is equal to 20, right? So I'm taking 6x as 6 and 4y as 14. So over here, I'm assuming x is equal to 1. It's also true as per statement 1, right? X just has to be less than 2. Now in this case, if I take 5x plus 5y, now over here, this 6 will become 5 and 14 will become 17.5. And 5 plus 17.5 is not equal to 20. So I'm getting a clear no over here, right? So in some cases, I'll get yes, and in some cases, I'll get a no. So these are not the only possibilities. Remember, I just took two values 1 and 20. I could have taken anything in between, and even the value of x could be anything from 0.001 to 1.999, right? So statement 1 alone clearly is not sufficient. Remember, over here I took 4y as 14. So if 4y is equal to 14, what is 5y? 5y will be 14 by 4 into 5. That's how I got 17.5 over here. Now we have arrived at statement 1 alone is not sufficient. Alright, what about statement 2 alone? Statement 2 says that $20 is enough to buy 12 oranges. So that means 12x is less than or equal to 20. Or that means x is less than or equal to 5 by 3, right? 20 by 12 is equal to 5 by 3. Now this is very similar to what was given in statement 1, right? Again, you will get the same scenarios, right? Even I could use the same plug-in values itself, because 0.1 and 1 are less than 5 by 3. Again, I'll get yes in some cases and no in some cases. Therefore, statement 2 alone is also not sufficient, and statement 1 and 2 together also do not add any value, right? They don't give me any extra value, right? Therefore, statement 1 and 2 together is also not sufficient, and the correct answer to this question is option E. That is, you cannot solve it even by using both the pieces of information together. Let's do this question. 1 kilogram of rice is a mixture of a kilogram of type X rice and B kilogram of type Y rice. The cost price of the mixture is R per kilogram, where R is equal to 5.4A plus 9.6B. Now the question is A less than 0.7? And statement 1 says B is greater than 0.2 and statement 2 says R is greater than or equal to 8.2. Now pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Now what are the informations that we can take out from the question stem? We know that R is the price per kilogram, right? So therefore A plus B has to be equal to 1. Alright. And again, we have R is equal to 5.4A plus 9.6B. So these are the two pieces of information that we have from the question stem. Alright. Now statement 1 says B is greater than 0.2. Is that enough to arrive at the answer? Let's plug in some values and check. Now say I take B as 0.21. Now in that case, A will be 1 minus 0.21, which is 0.79, right? Now in this case, is A less than 0.7? It's a no. So I'm getting a no. Now if I take B as 0.4, A will be 1 minus 0.4, which is 0.6. And is 0.6 less than 0.7? It's a yes. So sometimes I'm getting a no and sometimes I'm getting a yes. Therefore, this is definitely not sufficient. Statement 1 alone is not sufficient. Alright, what about statement 2? It says that R is greater than or equal to 8.2. So R is 5.4 into A plus 9.6 into 1 minus A. So for B, let me plug in 1 minus A. So 5.4A plus 9.6 into 1 minus A is greater than or equal to 8.2. So that's what's given in statement 2. Alright, now let's simplify this. I get 5.4 plus 9.6 minus 9.6A is greater than or equal to 8.2, right? So over here I have something with A, over here I have something with A. Let's club that together. So 5.4 minus 9.6, that's minus 4.2A, right? And over here, let me take this to this side, right? 8.2 minus 9.6, that's minus 1.4. So I'm getting minus 4.2A greater than or equal to minus 1.4. Now remember, whenever you have this type of an inequality, and if you have negatives, if you want to remove it, you need to multiply both the sides with minus 1. And if you do that, the sign will interchange. That is, greater than or equal to will become less than or equal to. Now we will cover this in detail in the section where we deal with inequalities. Alright, but it is good to have different concepts interlinked in different sections so that you also keep revising what you learn. So keep this in mind. This is a good point to learn. If you have an inequality, that is an equation where you don't have an equality, this type of less than, greater than, less than, equal to, greater than, equal to, all of these are inequalities, right? Now if you have any of these, now if you want to multiply both the sides of the equation with minus 1, the sign will change. So minus 4.2A greater than equal to minus 1.4. Therefore 4.2A less than or equal to 1.4. And therefore A less than or equal to 1.4 by 4.2, which is equal to 1 by 3. So we get A less than or equal to 1 by 3. Now if A is less than or equal to 1 by 3, is A less than 0.7? Definitely yes, right? 1 by 3 is 0.333. So if A is less than 0.333, definitely A will be less than 0.7. So we have a definite yes. Therefore statement 2 alone is sufficient, and hence the correct answer to this question is option B.